Hello guys, I'm Vanya S. Bapu from 1st PU Commerce of Micah PU College. Today I will be teaching about Arithmetic Progressions, which is the first chapter of 10th standard. So let's start the chapter.
Arithmetic Progressions, Class 10, Chapter 1. Importance of this topic. On this topic, in Class 10th CBSE and SSLC exam, you can expect questions worth 6 to 8 marks. So, let us look at some examples of AP. First example, 1, 2, 3, 4. Second example, 100, 70, 40 and 30. So here, as you can observe, there's something common in these numbers. Here, there is an increase in 1 and here there is decrease in 30. So that fixed term which the difference is there, that is called as common difference. And each number of a list is called a term. So an arithmetic progression, also called as AP, is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. Finding whether the given series of numbers is an AP. So let us consider example 2. In example 2, let us consider the first term as A1, the second term as A2 and the nth term as AN. Then the AP becomes A1, A2, A3 and it goes on till AN. So if the given series is an AP, then A2 minus A1 is equal to A3 minus A2. So here when we do it as A2 minus A1, 70 minus 10 comes as 30, minus 30. And when A3 minus A2 is equal to 40 minus 70, which is equal to minus 30. Hence, LHS is equal to RHS. Now we can say that the given list of numbers is an AP. Finding the common difference. So let us consider an example, 35, 65, 95 and 125. So the formula to find the common difference is AN minus 1, which is equal to D. Hence 65 is the second term and the first term is 35, which is A1. So A2 minus A1 is equal to 65 minus 35, which is equal to 30. Hence 30 is the common difference. So if there are only finite numbers in an AP, then it is called finite AP. If there are infinite numbers in an AP, then it is called infinite AP. The general form of an AP is A plus D, A plus 2D and A plus 3D. Some problems for practice. In which of the following situations does the list of numbers involved make an arithmetic progression and why? The taxi fare after each kilometer when the fare is rupees 15 for the first kilometer and rupees 8 for additional kilometer. So here they have given that A is equal to 15. So the starting fare is 15 and it keeps on increasing by rupees 8 for each kilometer. So hence, to find out the numbers of the AP, we put the general form. We substitute the given data to the general form. The general form is A plus D, A plus 2D and A plus 3D. So here we can see that A is equal to 15. A plus D is equal to 15 plus 8, which is equal to 23. And a plus 2d is equal to 15 plus 8 into 2, which is equal to 15 plus 16, which is equal to 31. So like this, the AP comes as 15, 23, 31 and 39. How to get to know whether the given list of numbers is right or wrong, whether it is an AP or not? We put the formula A2 minus A1 is equal to A3 minus A2. So if A2 minus A1 is equal to 8 and A3 minus A2 is equal to 8, then we got to know that it is the given number is an AP. Write first 4 terms of the AP when the first term A and the common difference D are given as follows. So they have given A as 10 and D as 10. So we have to find the AP, the first 4 terms of AP, that is A1, A2, A3 and A4 we have to find out. So here as you can see, A is considered as A1. So A1 is equal to 10. A2 is equal to 10A plus D, which is equal to 10 plus 10, which is equal to 20. A3 is equal to A plus 2D, which is equal to 10 plus 2 into 10, which is equal to 10 plus 20, which is equal to 30. A4 is equal to A plus 3D, so which is equal to 10 plus 30, which is equal to 40. So the first 4 terms of the AP are 10, 20, 30 and 40. For the following APs, write the first term and the common difference. So they have given the AP here and the first term is 0.6. To find the common difference, we have to put the formula A2 minus A1. So A2 is equal to 1.7. A2 minus A1 is equal to 1.7 minus 0.6, which is equal to 0.9. Hence, the common difference is 9, 0.9. Nth term of an AP. Nth term of the AP with first term A and common difference D is given by An is equal to A plus n minus 1 into D. An is also called the general term or the last term of the AP. If there are m terms in the AP, then Am represents the last term, which is sometimes also denoted by L. Some questions for practice. Find the 10th term of the AP 2, 7, 12 and it goes on. Here they have given the first term as 2, second term as 7. So to find D, we have to put the formula A2 minus A1. A2 minus A1, which is equal to 7 minus 2 is equal to 5. So n, the number of terms also known as n, is 10. When we put the formula An is equal to A plus n minus 1 into D, we get to know that A10 is equal to 2 plus 10 minus 1 into 5, which is equal to 2 plus 9 into 5, which is equal to 2 plus 45. Hence, the answer that comes is 47. So, the 10th term of the AP is 47. Which term of the AP 21, 18, 15 is minus 81? Also, is any term 0? Give reasons for your answer. Here, A is equal to 21. D is equal to A2 minus A1, which is equal to minus 3. And An is equal to minus 81. We have to find n, that is number of terms. As An is equal to A plus n minus 1 into D, minus 81 is equal to 21 plus n minus 1 into minus 3. So minus 81 is equal to 24 minus 3n. So if we shift 24 to this side, it becomes minus 81 minus 24, which is equal to 105, minus 105. And if n is left on the RHS, and if minus 3 is sent below, that is 105 by 3 minus 3, then minus minus get cancelled, and 35 comes. So n is equal to 35. Therefore, the 35th term of the given AP is minus 81. Next, we want to know if there is any n for which an is equal to 0. If such an n is there, then 21 plus n minus 1 into minus 3 must be equal to 0. So here, if we shift 21 to RHS, it will come as 3 into n minus 1 is equal to 21. So n becomes 8. So the 8th term is 0. Fill in the blanks in the following table given that A is the first term, D the common difference, and An the nth term of the AP. So they have given the first term, the common difference, the number of terms, and the last term. So here we have to fill the table. So let us look at one of the examples how to solve it. We put the formula An is equal to A plus n minus 1 into D. So 7 plus 8 minus 1 into 3 is equal to 7 plus 7 into 3, which is equal to 7 plus 21, which is equal to 28. In the following APs, find the missing terms in the boxes. So they have given the second and the fourth term. So A2 is equal to 13 and A4 is equal to 3. We know that An is equal to A plus n minus 1 into D. So A2 is equal to, they haven't given the first term, so we will keep it as A. N is equal to 2 minus 1, and the common difference also we don't know, so we'll keep it as D. So A2 is equal to 13. We can write this as 13 is equal to A plus 1D. And similarly, we can write the fourth term as 3 is equal to A plus 3D. By solving the equation, we get it as minus 2D is equal to 10. So D is equal to 10 by minus 2, which is equal to minus 5. Hence, D is equal to minus 5. And substituting the value of D in one of the equations, we get it as A is equal to 18. So the first term, that is A1, is equal to 18. To find the third term, we can put the general form, that is A plus 2D, which is equal to 18 plus 2 into minus 5, which is equal to 18 plus 10, which is equal to 8. Or we can also put this method, that is A plus n minus 1 into D. Hence, the missing terms are 18 and 8 respectively. The 17th term of an AP exceeds its 10th term by 7. Find the common difference. So we first put the formula an is equal to a plus n minus 1 into d. They have given a17 and a10. So they have given it as a17 minus a10 is equal to 7. We can write a17 as a plus 16d and a10 as a plus 9d. So instead of a17, we can put a plus 16d minus a plus 9d is equal to 7, which implies a plus 16d minus a minus 9d is equal to 7. A and a gets cancelled. 16 minus 9d is equal to 7. (16d minus 9d is equal to 7d. Therefore, 7d is equal to 7, and if 7 is shifted to RHS, it will be 7 by 7, which is equal to 1. Hence, the common difference is 1. Which term of the AP 3, 17, 27, 39 will be 132 more than its 54th term? So they have given the AP as 3, 15, 27 and 39. An is equal to a plus n minus 1 into d. So a is equal to 3, d is equal to 15 minus 3, which is equal to 12. N is equal to 54. So a 54 is equal to a plus n minus 1 into d. And here, as you can see, 3 plus 54 minus 1 into 12 is equal to 3 plus 53 into 12, which is equal to 639. So we got the 54th term as 639. Now we have to find the term which will be 132 more than 54th term. So 132 more than the 54th term is 639 plus 132, which is equal to 771. So an is equal to 771. And if we put the formula a plus n minus 1 into d again, we will get to know that n is equal to 65. Two APs have the same common difference. The difference between their 100th term is 100. And what is the difference between their 1000 terms? So we all know the formula an is equal to a plus n minus 1 d. Then the 100th term of the first AP will be a plus 99d. And the second term will be b plus 99d. So what they have given is the 100th term of the first AP minus the 100th term of the second AP is equal to 100. We know what a100 is. So a100 is a plus 99d minus b plus 99d, which is equal to 100. So a plus 99d minus b plus 99d is equal to 100. 99d minus 99d gets cancelled. So a minus b is equal to 100. Now we have to find the difference between the 1000 term. So what they have given is a1000 minus b1000 is equal to a plus 1000 minus 1d plus minus b plus 1000 minus 1d. A minus b plus 999d minus 999d. So here 999d and 999d gets cancelled. We know the value of a minus b. A minus b is 100. So the answer, the difference between the 1000 term of the two APs is 100. For what value of n are the nth terms of two APs 63, 65, 67 and 3, 10, 17 equal? First AP is 63, 65 and 67. So the first term is 63. The common difference is 2. To find the nth term of an AP, we put the formula an is equal to a plus n minus 1 into d. Hence, an is equal to 61 plus 2n. Let us consider it as equation 1. Second AP is 3, 10, 17. And if we put the formula an is equal to a plus n minus 1 into d, we get that an is equal to 7 minus 4. 7n minus 4. Now let us solve the equation. 61 plus 2n is equal to 7n minus 4. We get it as 5n is equal to 65 and n is equal to 13. So the 13th term of both these APs are equal to each other. Sum of first n terms of an AP. The sum of the first n terms of an AP is given by S is equal to n by 2 into 2a plus n minus 1 into d. We can also write this as S is equal to n by 2 into a plus n minus 1 into d. S is equal to n by 2 into a plus an. Now, if there are only n terms in an AP, then an is equal to L, which implies S is equal to n by 2 into a plus L. The sum of first n positive integers is given by Sn is equal to n into n plus 1 by 2. Some problems for practice. Find the sum of the first 22 terms of the AP 8, 3 and minus 22. Here A is 8, D is 3 minus 8 which is equal to minus 5 and n, that is the number of terms, is equal to 22. We know that S is equal to n into 2a plus n minus 1 into d by 2. S is equal to 22 by 2 which is equal into 16 plus 21 into minus 5. 11 into 16 minus 105 is equal to 11 minus 89 which is equal to minus 979. So the sum of the first 22 terms of the AP is minus 979. How many terms of the AP 24, 21, 18 must be taken so that their sum is 78? Here the first term is 24, common difference is 21 minus 24 which is equal to minus 3 and Sn is equal to 78. We need to find the number of terms. We know that S is equal to n by 2 into a plus n minus 1 into d. 78 is equal to n by 2 into 48 plus n minus 1 into minus 3 which is equal to n by 2 into 51 minus 3n. If we shift n by 2 and minus 3n to LHS, it becomes 3n square minus 51 plus 156 is equal to 0. N square minus 17 plus 52 is equal to 0. N minus 4 into n minus 13 is equal to 0. N is equal to 4 or 13. Both values of n are admissible. So the number of terms is 4 or 13. If the sum of first 7 terms of an AP is 49 and that of 17 terms is 289, find the sum of first n terms. Given S7 is equal to 49 and S17 is equal to 289. By using the formula Sn is equal to n by 2 into 2a plus n minus 1 into d, we have S7 is equal to 7 by 2 into 2a plus 7 minus 1 into d which is equal to 49. So 49 is equal to 7 by 2 into 2a plus 7 minus 1 into d. After simplifying, we get it as a plus 3d is equal to 7. Similarly, a17 is equal to 17 by 2 into 2a plus 17 minus 1 into d, which is equal to 289. After simplifying, we get it as a plus 8d, which is equal to 17. So by substituting equation 1 in 2, we get 5d is equal to 10 and d is equal to 2. From equation 1, a plus 3 into 2 is equal to 7. So a plus 6 is equal to 7 or a is equal to 1. Sn is equal to n by 2 into 2 into 1 plus n minus 1 into 2. N by 2 into 2 plus n minus 1 into 2. N by 2 into 2 plus 2n minus 2, which is equal to 2n, which is equal to n by 2 into 2 1 plus n minus 1. Hence, we get n square after simplifying. Show that a1, a2, an form an AP where an is defined as below. An is equal to 3 plus 4n. Also find the sum of first 15 terms. a1 is equal to 3 plus 4 into 1, which is equal to 7. a2 is equal to 3 plus 4 into 2, which is equal to 11. a3 is equal to 3 plus 4 into 3, which is equal to 15. Hence, d is equal to a3 minus a2, which is equal to 11 minus 7, which is equal to 4. After simplifying, we get the first term as 7 and common difference as 4. They have given the number of terms as 15. By putting the formula Sn is equal to n by 2 into 2a plus n minus 1 into d, we have 15 by 2 into 2 into 7 plus 15 minus 1 into 4. After simplifying, we get the answer as 525. Hence, the sum of first 15 terms is 525. A spiral is made up of successive semicircles with centers alternately at A and B. Starting with center at A of radii 0.5 cm, 1 cm, 1.5 cm, 2 cm as shown in the figure for 1.4. What is the total length of such a spiral made up of 13 consecutive semicircles? They have given to take the value of pi as 22 by 7. Try solving this problem on your own. After solving, we get the answer as 143 centimeter. Summary. Important points to remember. The general form of an AP is A plus D, A plus 2D and A plus 3D. If the given series is an AP, then A2 minus A1 must be equal to A3 minus A2. To find the common difference, we put the formula an minus 1 is equal to d. The general form of AP is A plus D, A plus 2D and A plus 3D. If the given series is an AP, then A2 minus A1 is equal to A3 minus A2. To find the sum of n terms, we put the formula S is equal to n by 2 into 2a plus n minus 1 into d. The sum of first n positive integers is given by Sn is equal to n into n plus 1 by 2. Thank you.